One of the more important is methane. Methane gas, natural gas, CH4 is its chemical formula. It's about 26 times more effective than carbon dioxide in producing climate change, in producing warming. On the other hand, there's a lot less of it, and it stays in the atmosphere for only about 12 years. It comes from many sources. We don't understand them as well as we do for carbon dioxide. Leaks from natural gas systems, from transportation, from mining. Agriculture produces lots of methane. Rice paddies, cows belch methane. Methane from a lot of sources. Rice paddies, landfills, sewage treatment plants, even some hydroelectric dams, particularly in the tropics, can actually produce more greenhouse warming than a coal-fired power plant because of the methane that comes from vegetation that's decaying on the bottom of the reservoirs. We don't understand fully, again, the balance of methane, but it probably contributes about a third as much to global warming as does carbon dioxide. And other significant gases are nitrogen oxides, the halocarbons, the gases used in refrigerants and so on, and ozone, a pollutant which in the troposphere actually causes the climate to warm, and in the stratosphere actually causes a cooling. But we do put other things into the atmosphere. We put aerosols into the atmosphere, a number of particulate matter, soot from burning coal, dust from industrial operations, but most importantly, sulfur from the burning of coal produces what are called sulfate aerosols, and they reflect sunlight and they exert a cooling effect on climate. Furthermore, they act as condensation nuclei for clouds and produce more clouds along with the greater evaporation that's occurring, and that also reflects sunlight, and those processes are pretty poorly understood even today. So we know that human factors also cause a cooling. We also know that that cooling is largely localized to the regions where these aerosols are produced, and we also know that that cooling can't overcome the warming we're causing with our greenhouse gases. But nevertheless, there is a cooling effect there, and we have to take that into account when we consider what we're doing to the climate. Just a few other things are land use changes that change the reflectivity of the planet, and although there are a balance of effects one way or the other, heating or cooling, the dominant effect we believe is a slight cooling. And I'll just mention one natural phenomenon that also affects Earth's energy balance, and that's changes in the intensity of sunlight, in the amount of power the sun puts out. And we have reason to believe the sun's intensity has come up a little bit in the time we're talking about here in the industrial era, but it's a much smaller effect than the human effects, and it is not a major contributor to global warming, although it does contribute slightly. Now, why do we attribute the recent warming to human activities? Well, I've just described you a whole host of human activities, from the burning of fossil fuels to changing land use patterns and so on, that should produce a net warming of the climate. Well, why, though, do we attribute the recent warming to human activities? First of all, there's that very strong correlation, which I've talked about and showed you, between carbon dioxide and global temperature. And that continues today with that unprecedented temperature rise of the late 20th century and early 21st century, corresponding to a very rapid rise in carbon dioxide. Now, I should also tell you, we don't expect those two to go right hand in hand year by year, because there's a lag time before the carbon dioxide that gets into the atmosphere produces the warming. So we don't expect a perfect correlation between those two. So if you see some places where maybe it was warming while the carbon dioxide was cooling while the carbon dioxide was going up, that's not a contradiction of this idea. But overall, the global trend should be a correlation of those two. More quantitative studies look at correlations in those reconstructions of the millennial temperature, for example. If you ask yourself, how much of this correlation is attributable to natural causes, particularly volcanic eruptions and variability in the sun, and how much is attributable to human greenhouse gases, you can sort that out mathematically. And what you find looking at those temperature reconstructions is that until the 20th century, the dominant explanation for what was going on, for the variations you saw, is natural factors, volcanism, and solar variability. But then you find that through the 20th century, the dominant factor in the explanation of those changes seems to be human-induced greenhouse gases. Now, I want to emphasize that discussion I've just given. That's all about observational data. Those millennial temperature reconstructions come from data, real data, from all that proxy data I described, coral reefs, tree rings, ice cores, and so on. So what I've just told you is that if you look just at data, this has nothing to do with climate models or any of that kind of thing, if you look just at data, you find that you can correlate past temperatures with three things: volcanism, solar influences, and the human greenhouse gas emissions. And that before the 20th century, the volcanism and the solar variability are sufficient to explain what you observe, but when you get into the 20th century, you need the human-induced greenhouse gases to explain what's going on. And so that argues strongly for a human influence on climate, at least in the 20th century and beyond. Now, we have also another completely independent argument from that one I just gave for why we expect a human influence on climate and why we expect that what's happening today is a result of human influence. We run computer models, and I'm going to say more about computer models in the next lecture, but computer models are large calculations that take into account the physics, the chemistry, the biology, all the atmospheric physics, the meteorology, everything that's going on in the climate system, and try to project what's going on. But what I'm going to talk about are computer model runs that don't try to project what's going to happen in the future, but rather start about 100 years ago and move forward in time and attempt to reproduce the present-day climate. And the beauty of the computer models is there we can do controlled experiments. So I'm going to show you a graph from some model runs, actually from an ensemble of model runs, so we're looking at an average of a number of climate model runs. And as you look at this graph, the black curve, the dark curve, the wiggly line, that's a thin line that's dark, that is the temperature record. Not exactly the same one I've been showing you before, but pretty much the same temperature record from observations over the time period from just before the start of the 20th century to about the year 2000 in this particular case. There are two wider bands on this graph, and the wider bands represent an ensemble of computer model runs. So they're wide bands because they represent an average, because each of these runs goes a little bit differently. All the runs were started with known conditions just before the start of the 20th century. So the computer models were fed with those conditions, and they were asked to reproduce the climate through the 20th century. And they were asked to do so, in one case, with only natural factors included. We know about the volcanism, we know how much dust volcanoes have put in the atmosphere, we know pretty much how the sun's energy output has evolved over this time. If we put those in, we get the lower of the two bands that you see on this graph. They're not terribly distinct through about the early part of the 20th century, or even the first half of the 20th century. And what that tells us is that either of those two sets of model runs does a pretty good job of explaining the climate, at least through the first half of the 20th century. The upper band represents climate model runs that include those natural factors, volcanism and solar influences, but also includes the anthropogenic greenhouse gases and also the cooling effect of those aerosols I talked about. So we think we've got most of the human influence included in these model runs. And it's very clear after the second half of the 20th century in these model runs that only the upper band, only the band that includes the anthropogenic and the natural effects, reproduces the observed temperature. So this is a very clear indication that we can't explain that temperature rise, at least not the rise of the late 20th century, unless we take into account the presence of anthropogenic effects, particularly the presence of greenhouse gases that tend to warm the climate, but also the effect of the anthropogenic aerosols that tend to cool the climate. That's all in here, and I think you'll agree looking at this graph that the model runs that include the human influence do a pretty good job of reproducing the entire temperature record, including that steep, unprecedented rise of the last part of the 20th century. So let me give a quick summary of this very important lecture. Human activities, especially burning fossil fuels, are adding carbon dioxide to the atmosphere, and Earth's energy balance is then upset in favor of a warming. In fact, today's CO2 concentration is some 40% above what it was before the start of the industrial era. There are other human contributions. There are other greenhouse gases, there are aerosols, there are land use changes, there are contrails from jet aircraft, I didn't even mention them. There are other factors that are also influencing climate, and we believe we've taken them into account. The greenhouse gases in particular produce a warming. Some of the other factors produce warming, some produce cooling, but we're taking them into account, and I will emphasize they're a little bit less certain, or quite a bit less certain, than the greenhouse influences. And finally, the natural effects can explain climate variation to at least the 20th century and maybe well into the 20th century, but if you want to explain the climate of the last few decades, you can't do it unless you take into account these anthropogenic effects. Human beings have had a real influence and are having a real influence on Earth's climate.